Landboards presents Undercounter lighting testing. We built up a 4-channel card onto our Grid 49 card. Here's the 2.1 millimeter connector attached, and here's the connections to one LED string. The LED string places LEDs about every 10 or 12 inches apart. Here's the kitchen cabinets with the lights turned off under the counter, and here's what it looks like with the under cabinet lighting turned on. We did that for a test, and the wiring is pretty sketchy with the attachments just being tacked on. What we really need to do is make some PC boards for this. We wanted to get on board fairly quickly, so we designed a small board with space for one LED and one 5mm terminal block like the other card has. It also has a mounting hole to help screw the board under the counter. It should be easy to connect up with having the terminal board as well. It could either be soldered or screwed in. The Oshpark order comes in at $3.20 for 3 boards, and that's with free shipping. Pretty good deal really when you think about it, and they're usually here within a couple of weeks. We also laid out a card with 4 LEDs on it. This is about 40mm by 40mm, and when ordered from Seed Studio should come in at about $10 plus shipping. That price is for 10 copies of the board, so 40 LED cards for about $10 or $15. Plan on cutting each of the 4 sections apart with a bandsaw, producing 4 separate cards. They have the same screw terminal holes as well. And finally, here's the 4-channel controller card. We added a 5th channel to the card and have a local string of LEDs that can be driven. This card can be then populated partially in some situations to allow for a smaller light to be built, and the other 4 chains can be driven out similar to the other prototype card, layout card that we did. The transistor is the same stand-up transistor, but it could be laid down on its side. What sort of enhancements could we do to this design? How about motion detection? Maybe use our X10 system to detect when someone's in the room, and if someone's in the room, turn the under-counter lights on. Otherwise, they could stay off. That could be pretty efficient. What about using an LDR, light-dependent resistor, to detect the lighting in the room and then dimming the lights if it's bright in the room? Well, under those cabinets it's pretty dark all the time, so I'm not sure that would be a great addition, but interesting thought. We did another project we called LED 18, where we had 18 LEDs, each driven by a transistor that was turned on, and that was all driven by an ATtiny 85 chip. That worked fairly well, but it was resistors in series, the ballast resistor style of design, and not constant current, so it really didn't achieve the LED brightness that we would like to. And these parts seem like they're a lot brighter. But the idea of using the ATtiny 85 and using, in this case we used the pot to adjust the brightness, and then drove those lines out to the LEDs as pulse width modulated lines to dim the lights, was a pretty attractive idea. Of course, that design suffered from the same issue that we had with driving the LEDs without using a constant current source, and that particular issue was a big part of the problem. It was very dependent in that circuit upon the voltage that you provided to it, and if the 12 volts was a little bit higher, a little bit low, you really couldn't take care of it without putting a bigger ballast resistor in there, which in turn weaken the effectiveness of the lights. But the idea of having an ATtiny 85 to control it was kind of cool. To work with an LDR, we could simply replace the ATtiny 85's analog pot input with a connection to an LDR, which would effectively do the same thing. Perhaps the transistor on this circuit could be used to switch the load voltage off and on, but the question I would wonder about would be, what would be the effect on the voltage regulator on the 12 volts with having load switched on and off on it? It'd be interesting to see if it had issues with that. For more information, check out our wiki page. We also have a YouTube channel where you can learn how to use these products, and we sell our products on Tindy. Thanks for watching our video.